another class. Last class we have discussed the principal stress and strain. So today let's solve few couple of examples. So first problem one is a rectangular bar of having a cross-sectional area 10,000 millimeter square is subjected to a axial load of 20 kilonewton. Determine the normal and the shear stress on a section on which is inclined at angle of 30 degree with normal cross section of the bar. So what is the question? Let's draw the diagram first. A rectangular bar. So let's draw a rectangular bar here. A rectangular bar. A rectangular bar of cross sectional area. Cross sectional area is given. A is already given to you. So it is 10,000 A. Now is subjected to a axial load of 20 kilonewtons. So axial load is applied 20 20. So now you can see axial load is applied to 20 kilonewton. Determine the normal and the shear stress on a section which is inclined at an angle of 30 degree. So now consider a section here. Consider a section. So this angle will be this angle will be 30 degrees. So this is our section. I'll just draw it in some other color. So this another section I have taken, and this angle is basically 30 degree. Now the question is, you have to find it out the normal and shear stress in this section you have to find out inclined section which is 30 degree from the 30 degree is not this angle, actually 30 degree is this angle. Let's draw it. So this angle is your 30 degree. That is the question. So cross sectional area A is given to you 10,000 millimeter square. P axial load is given in 20 kilonewton if you convert it into the Newton. So now this angle is given to you 30 degree. Then what is the direct stress on this plane? So on this plane will be force into cross sectional area. So force is already 2000. So now I am talking what is the normal stress in this section. I am finding out. But the question said you have to find out what is the normal and shear stress in this inclined section. But let's first find out what is the shear stress and inclined stress in the vertical section. Then we'll just transfer it to the oblique plane. So now direct stress is P by A. So it is 2000. P is actually 20,000 Newton and A is 10,000 millimeter square. So we will get 2 Newton per mm square is the direct stress in this plane, vertical plane. Now sigma n we considered is a normal stress on oblique plane. So oblique plane is this one oblique plane. So now we considered sigma n is a normal stress in this oblique plane. That actually we have to find it out. Similarly, shear stress sigma t on a oblique plane. So these two value actually we have to find it out. So now using this equation whichever we have discussed last class, sigma n. So normal stress in this plane was, if you remember, sigma cos square theta. That equation we have derived last class. So just substitute the value. Sigma is 2 into cos square theta is here 30 degree. So just substitute the value, you will get what is the value of sigma n. Similarly, for shear stress equation last class we have derived this equation sigma t equal to this equation we have derived last class. So just substitute the value now. 2 into theta is 30 degree, you will get shear stress here. So that's how you. So this is 1.5 Newton per mm square is the normal stress in this oblique plane, and 0.866 is the shear stress in this plane. Just we substituted our already we derived these two equations in the last class. So just here we substituted it and we got our final value. Now let's solve another problem here. Very important problem here. A rectangular bar of cross-sectional area 11,000 millimeter square is subjected to a tensile force of P as shown in figure. So you can see this is a figure. So this is a rectangular block and cross-section is given to you So cross section is given, it is actually 11,000. So P is applied. So tension force is applied, subjected to that. Now the permissible normal and the shear stress on a oblique plane. So this is oblique plane which is 60 degree from horizontal. So this 60 degree, the permissible normal and shear stress on an oblique plane is given 7 Newton per mm square and 3.5 Newton per mm square. Determine the safe value of load P. So what is the question here? So this is the oblique plane they considered, and which angle is actually 60 degree from the x-axis. So this is your x-axis. So this angle 60 degrees with respect to x-axis. Don't remember our last problem, whatever angle or whenever we derived our formula, that angle actually we have considered from vertical plane. So if you have a section here, so first we consider a vertical section and then we draw a oblique section. So whatever formula we have derived, that is our theta. Okay, so this is the load P. So when we derived our equation, we consider this angle as a theta, that is with respect to vertical plane. So please remember here, this angle is given with respect to horizontal. So while using our formula, basically you have to convert so this equation into it. So this angle will be 30 degree. So now what is given is this angle. So this section is BC, which is basically 60 degree, making 60 degree angle towards the x-axis, and the permissible normal stress and shear stress is given 7 Newton per mm square and 3.5 Newton per mm square. So what is permissible stress? Means when stress reaches, when the stress in this plane BC crosses this value 7 and 3.5 normal stress and shear stress, then your material will simply break. So you are applying P force in this direction, P force in this direction. Similarly, you are applying P force in this direction. So basically, you are pulling this entire material. So when the stress in this section is crossing the value 7 and 3.5, then your material will break two part. So this part will come out, this part will come out. So there will be break in this section. So when the stress reaches to this two maximum value, this your block will be now two parts, separated into two parts. Now the question is to calculate what is the load P, safe load. So question is you have to find it out what is the safe load P where the material won't break up. So what is the final force, this final load this material can take, that you have to calculate the P force. So let's see whatever is given to us. So its sectional area is given 1100 mm square. Now similarly normal stress is also given 7 and shear stress permissible. So in this section the stress is already given. Now you have to find it out P. So it is a reverse problem. Whatever we solve problem 1, this is just a reverse of this problem 1. So this P, so the normal stress and shear stress is given to you. You have to find it out now P. What is the safe load? So a angle is given 60 degree with this respect. So but whenever we use our formulas, equations, then we will use 30 degree because when we derived our formula, our angle we considered with respect to the vertical section. So now angle in the BC with the normal cross section is just 30 degree. So total is 90 degree minus 60 degree, 30 degree. So this angle basically we are finding out. So P is the value of safe. So sigma is the stresses on this member. So we considered sigma in this vertical member. What is the stress? Say normal stress is sigma. So as per our equation, what is this? What is the normal stress on this plane, on this oblique plane? Is sigma n is equal to sigma cos square theta. So sigma n is given to you now. That is 7. So just substitute 7. Sigma n is the normal stress on an oblique plane. 7 is given. 7 is equal to sigma cos square theta value also you know 30 degree. So now from here you calculate what is the value of sigma. Just substitute the equations, you will get sigma is equal to 9.334. So now you know what is the value of sigma. So from sigma now you have to find it out the load P as well. So another equation is given like shear stress. We have equation sigma t equal to sigma 2 by sine 2 theta. Just substitute the value. So sigma t value is given 3.5. So 3.5 into theta's value is 30 degree. So just substitute, and here also you will get another theta, another sigma. So this is another sigma. So now you see there are two sigma. From using normal stress you got 9.334, and then using shear equations you got another sigma, that is 8.083 Newton. So first sigma, so out of these two sigma, which one is lower? So when your material reaches to that value, it will be crossed. So see, now you have 9.833 and you have 8.3. Now the question is, which one will you take? Both are actually sigma. So when the sigma reaches to 8.083, then only your material, this section will be failing because of shear. So this section never reaches to the sigma this value. So sigma will gradually increase, right? Sigma will gradually increase with load, with strain. So we will have epsilon strain, and sigma is basically stress. So stress is gradually increasing. So this is at the beginning there is zero. So you are increasing the load P. It is, the stress is also increasing. After certain point, when stresses reaches to 8.083, your this section, this oblique plane will fail because it reaches to its maximum permissible value. So which one is lesser? There only your section will fail. So that will be our maximum stress that section can take. So the safe stress will be not this one but 8.033, because when stress reaches to this value, then only your material will be collapsed. It never reaches to 9.33 because in 8.08 only the material will be collapsed. So the safe stress will be this much. Now if you find out P will be how much? So already we know what is stress. Stress equal to force by area. So now you know the stress. Stress is 8.33. A also you know. Just find out P. So P equal to sigma A. Sigma A. So sigma's value you know 8.03, and A's cross section value also given. Just multiply, you will get the safe value. So what is the ultimate conclusion in this problem? So when the P value reaches to 88.913 kilonewton, your material will break into two parts, and the failure will happen shearing failure, because shear force reaches first. So that is the conclusion of this problem. So like that you have to solve you have to calculate what is the stresses in an incline.